Most people fail system design interviews not because they don't know technology, but because they don't know how to structure their answer. And honestly, that's fair because most resources either jump directly into designing Instagram or they just throw random buzzwords like Kafka, sharding, Redis, load balancer without explaining when and why to use them. So, in this video, I'll give you a simple step by step framework that you can use to approach almost any HLD or system design interviews. After this framework, we'll actually use it on real questions like URL shortener, notification system, and more. So let's get started. Starting with our first section, requirements. Now, the very first mistake people make is they start designing immediately. Please don't do that in interviews. Your first job is to understand the problem properly. Read the requirements thoroughly. Understand them. You need to ask clarifying questions. Why? Because system design interviews are intentionally vague. Example, if I say design notification system, there are already so many unanswered questions, push notifications or emails, real time or delayed, millions of users or thousands of them, retry mechanism needed or not. And depending on these answers, your entire architecture depends. Coming on to the functional versus non-functional requirements. Now, usually requirements are divided into two categories: functional requirements and non-functional requirements. Functional requirements are what the system should do. Example, send notifications, store messages, generate short URLs. While the non-functional requirements are how well the system should do it. For example, scalability, reliability, low latency, high availability. This distinction is super important because functional requirements define features while the non-functional requirements derive our architecture decisions. This is where interviewers start understanding whether you think like an engineer or just memorize components. Coming on to our next section, scope, defining scope and prioritizing. Now, once requirements are clear, don't try to solve the entire internet here. In interviews, time is limited. So define what is in scope and what is out of scope. Focus first on must have features, then, if time allows, discuss advanced features. For example, in a URL shortener, generating short URL may be a must have feature, but analytics dashboard may be a nice to have feature. This keeps your design structured instead of chaotic. Now, coming on to the most important section that we are going to discuss is identifying the key components and services. Now we move to the actual architecture part. This is basically where you break the system into major building blocks. As you can see in this example, there is API gateway, load balancer, services, cache, database, and queue. Think of this like what are the major pieces needed to make this system work. Now, apart from the components, one very important thing that we have to discuss is how components communicate, what data they exchange, and where the request flows. I personally use this mental model here. Let me explain. So, the interface is how the services talks. You can see the example here. While the data contract is what they say, basically the things they return. For example, in this user, the ID, email, name, this is returned. And the data flow is where the message goes. In this, we can clearly see that the gateway sends message to booking service to cache and DB, and payment service to queue, which then triggers the notification system, as we have seen here as well. Coming on to the next section that we have to discuss, after we have discussed the components, we have to think about the data. What entities exist in our system? We have to think about the data and what entities exist in the system. For this as well, I have created this example here. You could say that example for key entities are user, there is user ID, email, name, created at. This is the entities that are stored in our DB. For order, message, and URL mapping, this is the key. You should also define APIs between services. You obviously don't need production level APIs in interviews. High level contracts are enough. You can see this here as well, how I have defined the services. And one very useful thing that I have been using is reusable sentence structure, where is this reusable sentence structure. Service X exposes an API for purpose which is used by service Y to reason. Example, user service exposes an API for the purpose is fetching user details, which is used by the order service, the reason to attach user info to the orders. Coming on to our next section, we have to address the scalability and performance as well. Now, this is the section where most interviewers become interested, because now you are going to solve real engineering problems like increased loads, data partitioning, and asynchronous processing. These are the few examples and techniques that is used to tackle this. One could use this mental model that I am showing right now, like if there are more number of users, add servers. If the read is slow, frequent reading is needed. For example, in a URL shorter service, add the caching. There is huge data, large number of data, then sharding the data base. And if it's a heavy task, we have to use queue, which is asynchronous processing. Coming on to the next section, reliability and fault tolerance. One could say why we are discussing this, but systems fail, servers crashes and database go down, and network sometimes time out. Good system design assumes failure will happen. For this, we have some techniques to overcome these challenges. Like we keep replicas, so if one server fails, another can take over. This is replication. Failover mechanisms. Backup system automatically becomes active. In retries, try fail request again while the circuit breaker stops continuously hitting already failing services. Retries, try the failed request again but the circuit breakers stop continuously hitting the already failed services. This prevents one bad service from bringing down your entire system. Coming on to the security and compliance part, this section is often skipped by the beginners, but mentioning it immediately makes your design look mature. Mention things like authentication, authorization, encryption, audit logs, role-based access. You don't need deep cybersec knowledge for this, but you should acknowledge security concerns. Coming on to the trade-offs and alternative part, we'll discuss this in detail when we'll be solving the problems, but this is honestly one of the most important sections in senior interviews because in real engineering there is no perfect solution and only trade-offs. For example, SQL versus no SQL, consistency versus availability. Your goal is not to proving one technology is best. Your goal is proving your understanding to why a choice is made is good or not. Senior engineers are judged less on memorization and more on decision making. Now, coming on to the diagram, there are like three types of diagram generally used by us: the block diagram, the flow diagram, and the sequence diagram. Here are the examples I have prepared in advance. The all three of them have different purposes. The block diagram shows what exists, the flow chart shows what happens, and sequence diagram shows who talks when. In this example for block diagram system architecture, you can see there is client application, load balancer, API services, and databases. While in the order processing example for the flow chart, the we know what the request does. For example, it we receive a order, we validate if the payment has been made or not, and depending on it, we do the task. If it is valid, we'll ship the product, otherwise, we'll reject it. And in the sequence diagram, uh, we in this example, we can see that the user service talks with the auth server. It provides with the credentials and get back the JWT token, while the auth server talks with the DB, which verifies the user data using the database. Coming on to the final section, summarizing and review, we don't have to stop abruptly. We have to recap the architecture, requirements, scaling, reliability, and trade-offs that we have already discussed. And we would then ask the interviewer, would you like me to dive deep into this section, like discuss it again or in more detail? This shows collaborative thinking. So, this was a complete framework you can use for almost any HLD interview questions. And in the next video, we'll actually use this exact framework to solve real problems like URL shortener, notification system, Instagram feed, and many more. Because knowing theory is useful, but applying it is where real understanding begins. Thank you for watching. See you in the next one.